Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet. So now we are looking at this, but we are still continuing with the projectile. We thank you for your time. Don't forget to subscribe and to like and to comment and to refer the channel to a friend. Yes, what are equations of motion? Now, these equations were put across by Isaac Newton, to try to explain the behavior of bodies which are moving, especially those which are moving with a fixed acceleration. Okay, let's look at the first one. The one which comes first is this one. Vf is equal to Vi plus A delta T. Yes. This equation actually came from the definition of acceleration. If you remember acceleration, what is acceleration? We said it's the rate of change of velocity. So when you rearrange this equation, you get that first equation of motion. So it's not very far from what we have been doing all along. The second equation says Vf squared is equal to Vi squared plus 2A delta X. Okay. The next equation says delta X is equal to Vi delta T plus a half A delta T squared. Okay. Now, these equations have one thing in common for all of them. They have acceleration. It's the only factor which is common in all of them. Then comes this one, which is missing acceleration. What does it say? It says delta X is equal to Vf or Vi plus Vf. This is over 2 into delta T. This is the equation which we know it, because what is here is average velocity. So it's going to be average velocity times time. Remember, S D is equal to S times T. This is it. This is the T. This is the S. This is the D. Only that here you are given a situation that suppose velocity changes. So these are the equations which you are going to be using. They are going to be our traditional equations. But we need to know what each of these stands for. Vf is final velocity. Okay. Vi is initial velocity. A is acceleration. And for projectile, A is equal to G, where G is acceleration due to gravity. But if the body is not a projectile, we don't have to use G. Delta T is change in time. Delta X is change in displacement. So those are what are the terms we have in these equations. Yeah, then comes this part. Use of the equations of motion. Okay, here, these are the principles which we base on when we are substituting in the equations of motion. I hope we understand them. Let us look at the first scenario. The first one is projected upwards. Okay. Yes. So we are having this scenario projected upwards, and we are taking upwards positive. So this is what we normally do. I would urge you to do the same. Meaning, this is the projection. It's upwards. And what you have here, this is the projection. This is the direction taken. So when you look at here, the body is projected upwards and you have taken upward positive. What does that mean? That means that our initial velocity is positive. Okay. Then what else is important? What is important is G. Yes, the body is projected upwards. What is going to be our G? You have to remember that the G is always acting vertically downwards. So G is going in opposite direction to what we have chosen, because we took upward positive and the body is going upwards. So G is going downwards. So under this circumstance where the body is projected upwards, G is negative. Okay. Then what else do we know? Time doesn't matter, but delta X matters. Yes, delta X matters. If positive, we can make conclusion. And what is that conclusion? Above point of projection. Okay. And if delta X turns out if negative, what does that mean? It means the point under consideration is below. Below point of projection. So that is very important to take note. Yes, then we come to this one, downwards, positive. Okay. How do we deal with this? Okay, this is what you have to know. First of all, yes, then it comes to this one, downwards, positive. What does that mean? This is what it means. First of all, it means that the body is projected upwards. This is projection. And it means that the direction we have taken upward, downward is the one which is positive. Okay. Under that circumstance, what do we do? So this is what we have to remember. Let's start with VI. Our VI, VI is the initial is the initial velocity and is projected upwards. But we have taken downward as our positive, which means upward is what? Negative. So our VI is going to be negative. Okay. From there, let us go to our G. Yes. Our G, what is it? The body is projected upwards. And we have taken downward as positive, and the G is going downwards. So it means that our G is going to be positive. Then we come to our delta X. Yes, delta X, remember, we took downward positive, which means that the distance above the point of projection is negative. So what are you going to say? Yeah, that if negative, what does that mean? It means above point of projection. Okay. And we say if delta X, if positive, actually, let's change that one. If positive, what does that mean? It means below point of projection. So that is that. Yes, then we come to this scenario. The body is projected downwards, but we have taken upward as positive. Okay, this is what we have to know. The projection is downwards, but upward is the direction we have taken as positive. What does that mean? Let's start with the initial velocity. Now you have to remember that initial velocity, the body is projected downwards, yes, and we have taken our upward as positive, which means that if the body is going downwards, it's going opposite to our direction, which we have chosen as positive. So answer is going to be negative. Okay. From there, what else do we need to know? G. Okay. G is always acting downwards, but we have taken upward as positive. What does that mean? That our G is going to be negative. That one is very important. Okay, let us go to our delta X. Okay, now delta X, the body is covering the distance, going downwards, but we have chosen upward as our positive, which means that our delta X is going to be always negative. This time we don't have a chance of one being positive and being negative. It's always negative. Yeah, then lastly, we come to this one, downwards positive. So what does that mean? It means that the ball is going downwards. And what does that mean also? That we have chosen downward as positive. So here, what are we going to have? Let us look at VI. Our VI is going to be, remember VI is in the same direction which we have chosen as positive. So it's going to be positive. Okay, let us go to our G. G is always acting downwards, and the downward is positive. So our G is going to be positive. Okay, let's go to displacement. Our displacement covered this time around, remember, it's going downwards, and downward is positive. So it's also going to be positive. So with that, would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. Don't forget to subscribe. Don't forget to like. We are simply the best.